Welcome back. In today's video, we will sketch graphs of absolute functions where the function inside is linear. Before we begin, make sure you are confident with sketching straight line graphs such as y is equal to x, y is equal to 2x minus 1. Identifying x and y intercepts. Understanding the concept of absolute value, that is modulus of x. Let's do the sketching of y is equal to 2x minus 1. First of all, we will take out x-intercept and y-intercept. For x-intercept, we have to take y value as 0. So we have 0 is equal to 2x minus 1. X is equal to 1 upon 2. For y-intercept, we will take x value as 0. So we have y is equal to 2 into 0 minus 1. So y is equal to minus 1. We have coordinates 1 upon 2 comma 0 and 0 comma minus 1. We'll mark these points on the grid. We have here 1, 2, 3, and 4. Minus 1, minus 2, 3. Here we have minus 1, minus 2, and minus 3. We can mark the point over here and here at 1 upon 2 comma 0 and at 0 comma minus 1. We'll draw the line passing through these points. As these 2 points are very close, so we can take one more value of x. Or we can take the value of x as 2. Y will be equal to 3. So at 2, the value of y is 3. So we can mark this point over here. Now we can easily draw the graph. So this is the graph of y is equal to 2x minus 1. This is x-axis and this is y-axis. Now we will do sketching of the graph of y is equal to absolute of x. It is very easy to draw the graph of absolute of x because first you have to draw the graph of y is equal to x in which y and x values are same. Then reflect in the x-axis the part of the line that is below the x-axis. So let's draw the graph of y is equal to x. We have here 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Here as well, we can mark minus 1, minus 2, minus 3, minus 4, minus 5. And here, minus 1, minus 2, minus 3, minus 4, and minus 5. We can mark the points here. We have 1 comma 1. We have 2 comma 2. We have 3 comma 3. We have 4 comma 4. And here we have minus 1 comma minus 1, minus 2 comma minus 2, minus 3 comma minus 3, and minus 4 comma minus 4. Now we will draw the line passing through these. We have to reflect the part of the curve which is below the x-axis. Like if we have here -1, -1, now this will become -1, 1. All negative values of y will become positive. So at -2, it will be 2. At -3, it will be 3. And at -4, it will be 4. So the line which was below the x-axis now will be above the x-axis. Now we will draw a line passing through these points. We can erase the part of the curve which is below the x-axis. So we can erase this part and all these points. So this is the graph of y is equal to absolute value of x. Now we will sketch the graph of y is equal to 2x minus 3, showing the coordinates of the points where the graph intersects the x-axis. Where the graph intersects the axis means x-axis and y-axis. It's a plural of x's. First of all, we'll analyze the equation. We have y is equal to 2x minus 3 with an absolute sign. So it means that we have to draw the graph of 2x minus 3. Then we have to reflect in x-axis the part of the curve which is below the x-axis. This is one of the way. Another way is first take out the vertex and then the x-intercept and y-intercept. For vertex, we have to equate 2x minus 3 to 0. X is equal to 3 upon 2. And if the whole equation is inside the absolute sign, then the y value at vertex is 0. So y is 0. So vertex is 3 upon 2, comma 0. And we'll mark this on the grid. We have here x, we have here y. We have 1, 2, 3, 4, 5. 3 upon 2, which is 1.5, is here. So this is the vertex, and this is also x-intercept. For y-intercept, we can take the value of x as 0. So it is y is equal to minus 3. This is y-intercept in the original graph. Here we have -1, -2, and -3. When the line will reflect in x-axis, this -3 will be above the x-axis. So it will be at 0, 3. Now we have one of the point on this side of the vertex. We can find out another point on right hand side of the vertex. So if we take the value of x as 3, it is 3. So at 3, we have to mark the point at 3. One of the line is from here till here. Another line will be on this side. So you can see it's a V-shaped graph. So whenever you have to draw a graph of absolute function where function is linear, then it is to be a V-shaped graph. We have to first take out vertex, and then we can take one of the value of x on right hand side of the vertex and another point on left hand side of the vertex. So this is the graph of y is equal to 2x minus 3. Another question in which we have to draw the graph of different functions. we see we have here y is equal to absolute of x minus 3. In this question, we just have x in the absolute sign. So first of all, we will take out vertex. For vertex, we equate the expression which is there in the absolute sign. So we have here x, so it is simply is equal to 0. So when we will equate this value over here, then we get the value of y at vertex. So here we have y as minus 3. So the coordinates of vertex are 0, minus 3. Let's mark this vertex on the grid. We have here x, we have here y. We can mark the points here 1, 2, 3, and we can mark here -1, -2, -3, -1, -2, -3. Vertex is at 0, -3, so it's here. Now, we can take one of the value on the right-hand side of the vertex and another value of x on left-hand side of the vertex. So we can take here the value of x as 3. So it is y is equal to 0. Another value of x we can take as -3. So when we will take absolute of -3, it is 3. So 3 minus 3 is equal to 0. So at 3 it is 0. At -3 as well, it is 0. We can draw a line passing through these points. In the same way, we will draw a line on this side of the graph. So this is a V-shaped graph. It is the graph of y is equal to absolute of x minus 3. Let's do another kind of equation in which we have y is equal to 2 minus absolute of x. Now you see there is minus sign before the absolute sign. So it means in this case, the graph will be an inverted V. It will be like this. So whenever there is minus sign before the absolute sign, it means that the graph is to be inverted V. Now we will do the same thing. We will first take out the vertex. For vertex, we will equate the expression which is there in the absolute sign to 0. So here x is equal to 0. And when we will substitute here 0, then we will get y value as 2. So 0, 2 is the vertex. We'll mark this point on the grid. We have here x, y, 1, 2, 3, 4, -1, -2, -3, -4, -1, and 2. This is the vertex, 0, 2. Now we have to take one of the value of x, which is on right-hand side of the vertex, another value on the left-hand side of the vertex. So we can take the value as 3 and -3. So when we will take here 3, so it will be 2 minus 3 is -1. Then we will take the value of x as -3. So when we will take -3, then also it is -1. Because absolute value of -3 is 3. So 2 minus 3 is -1. Now we can mark these points on the grid. We have 3, minus 1. So minus 1 is over here. And minus 3 comma minus 1. Now we can draw the graph passing through these points. Another line on this side of the vertex. So you can see it is an inverted V. It is the graph of y is equal to 2 minus absolute of x. And let's draw a graph of equation in which we have an expression x minus 3. In the absolute sign, there is plus 1 outside. So the first thing is to take out vertex. For vertex, we equate the part of the equation which is in the absolute sign. So x minus 3 is equal to 0. So x is equal to 3. And when we substitute this x value over here, 3 minus 3 will be 0 and we will be left with 1, which is the value of y. Now the vertex is 3 comma 1. Now we'll mark this vertex on the grid. We have here 1, 2, 3, 4, 5, 6. We can mark here 1, 2, 3, and 4. The vertex is at 3 comma 1. So it is here. Now we will take one of the point on the right hand side of the vertex and another value of x on left hand side of the vertex. So we can take one of the value of x as 0. Absolute of minus 3 is 3. 3 plus 1 is 4. At 0, it is 4. So another value we can take as 6. You can take 4 or 5 or 6. Any value you can take. But we are taking here 6. So 6 minus 3 is 3 and absolute of 3 is 3. So 3 plus 1 is 4. So at 6, it is 4. So you can mark the point over here. Now we will join this vertex with this point and with this point. So this is the graph of y is equal to absolute of x minus 3 plus 1. Another question in which we have to find the range. Given that each of these functions is defined for the domain x is greater than or equal to minus 3 and less than or equal to 4, find the range of 5 minus 2x. So we will be taking the value of x as minus 3, the least value and the greatest value to find out the range as it is a linear function. So first of all, we will take f of minus 3. So f of minus 3 is 5 minus 2 into minus 3, which will be 11. Then we will take f of 4. We will substitute 4 in the equation, in the function. So we will get 5 minus 8 is equal to minus 3. Now we can write range. Range is to be written in the form f of x is greater than or equal to minus 3 and less than or equal to 11. The least value here and the greatest value here. Now we have g of x is equal to 5 minus 2x. First of all, we will substitute here minus 3. When we will substitute minus 3 here, then it will be equal to 11. And when we will substitute 4 here, then it is 5 minus 2 into 4, which is equal to 5 minus 8, which is minus 3. And absolute value of minus 3 is 3. It is an absolute function, so we have to consider vertex as well. For vertex, we will equate this 5 minus 2x to 0. 5 is equal to 2x and x is equal to 5 upon 2. When x is 5 upon 2, then y value is 0. The coordinates of vertex are 5 upon 2, comma 0. Now we will write range here. Range of g of x is greater than or equal to 0. 0 is the smallest of all three values, less than or equal to the greatest value, which is 11. So the range is from 0 till 11. Let's do this one. In this, we have 5 minus absolute of 2x. We'll substitute the value of x as minus 3. So 5 minus an absolute sign minus 3 is equal to 5 minus absolute of 2 multiplied by minus 3 is minus 6. So we have 5 minus absolute of minus 6 is 6. So we have here minus 1. Then we will substitute here 4. So 5 minus 2 into 4, which is equal to 5 minus absolute of 8. So absolute of 8 is positive, so it will remain positive. 5 minus 8 is minus 3. This is an absolute function, so we have to consider the vertex as well. For vertex, we will equate this 2x to 0. So it is x is equal to 0. And y value would be, when we will substitute here the value of x as 0. So we have y is equal to 5. So vertex is 0, 5. Now we will write down the range. We will consider the smallest value of all these, which is minus 3, and the greatest value, which is 5. So the range of h of x is from minus 3 till 5. Now we will do a past paper question related to graphs of absolute function when the function is linear. We have to sketch the graph of y is equal to 5x minus 3 on the axis below, showing the coordinate of the points where the graph meets the coordinate axis. It means x-axis and y-axis. So first of all, we can take out vertex. For vertex, we equate the part which is within the absolute sign to 0. So 5x minus 3 is equal to 0 and x is equal to 3 upon 5. When we will substitute the value of x as 3 upon 5 in the equation, we will get the y value as 0. So y is equal to absolute of 5 into 3 upon 5 minus 3, which will give the result as 0. So we have vertex 3 upon 5, 0. Now we will plot this on the grid. We have here 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. So it's 3 upon 5, 0 means 0.6, 0. So the vertex is over here. Now we can take one of the point on right-hand side of the vertex and another point on the left-hand side of the vertex. So for the point which is there on the right-hand side of the vertex, we can take 2. So y is equal to 5 into 2 minus 3, which is 7. Then we can take the value of y as minus 1 on this side of the vertex. So when we will take here minus 1, it would be minus 3. So minus 5 and minus 3 would be minus 8. So the absolute value of minus 8 is 8. We have coordinate 2, 7, another coordinate -1, 8. You can mark the points over here. At 2, it is 7. And at -1, it is 8. Now, we can join these points. So this is the graph of y is equal to absolute of 5x minus 3. As we have to show the coordinates of the points where the graph meets the coordinate axis. So one of the point is here, which is 3/5, 0. Another point is here, which is 0, 3. We can find out this y-intercept by substituting the value of x as 0 in the equation. So we have here absolute of -3, which is 3. Part B, in which we have to solve the equation absolute of 5x minus 3 is equal to 2 minus x. One time we will take 5x minus 3 is equal to 2 minus x. Another time we will take 5x minus 3 is equal to -2 plus x. 5x plus x is 6x is equal to 2 plus 3 is 5. So x is equal to 5/6. 5x minus x is 4x and -2 plus 3 is 1. So x is equal to 1/4. So these are the values of x for this equation. Then we can check whether these values of x are satisfying this equation or not. 5 into 5/6 minus 3 is equal to 2 minus 5/6. So we have here 25/6 minus 3 is equal to 7/6. So this is 7/6. Absolute of 7/6 is equal to 7/6, which is satisfying the equation. Here we have 5 into 1/4 minus 3, which is equal to 2 minus 1/4. So it is 5/4 minus 3. And it is 7/4. This is minus 7/4. So absolute of minus 7/4 is 7/4. This value is also satisfying the equation. A quick recap. Modulus means absolute value. All y values stay non-negative. To sketch, y is equal to f of x, reflect the portion of f of x below the x-axis. This is the case in which we have whole expression in absolute sign. But in case the whole expression is not in absolute sign, then we take out the vertex, we mark the vertex, then we take out one of the point on left-hand side of the vertex and another point on right-hand side of the vertex, and then we draw the graph. And if there is minus sign before this, then it means that the graph would be an inverted V. Always find x and y intercepts before sketching. Domain is usually given. Find range by checking minimum and maximum values. Modulus graphs may look tricky at first, but once you learn to reflect and interpret them, they become a powerful visual tool. Keep practicing and soon you will master them. Subscribe to Samathics for more lessons like this, simplified and exam ready.